Hi, I'm Thomas. Welcome back. Our topic is trigonometric identities. This is example 1. We read, solve the equation 4 times cosecant theta squared minus 9 equals cotangent theta in the interval 0 is less than or equal to theta is less than or equal to 2 pi. For our trigonometric identity problems, we have a 4-step algorithm. Step 1, identify scenario. When you're using identities, you'll either be dealing with an identity, you're given one side of an identity, and you're asked to manipulate that side of the identity to exactly match the other side of the identity. The other scenario that we'll see, which is what we see here, is an equation. We are going to solve for a variable. In this case, that variable is theta. So step 1, identify scenario. This scenario is an equation. Step 2, identify relevant trigonometric identity. In order to do that, we need to understand more about this equation. The cosecant theta squared gives me a clue. This is a quadratic. So first I'm going to rearrange the equation. 4 times cosecant theta squared minus cotangent theta minus 9 equals 0. In solving this quadratic, I want to work with one trigonometric function. Right now I have 2, cosecant and cotangent. And we have an identity that connects these 2 trigonometric functions. It's one of our Pythagorean identities. Cotangent theta squared plus 1 equals cosecant theta squared. Now in step 3, we will substitute. So 4 times what was cosecant theta squared is now going to become cotangent theta squared plus 1 minus cotangent theta minus 9 equals 0. From here, step 4, we simplify to solution or solutions. We'll distribute the 4 to get 4 times cotangent theta squared plus 4 minus cotangent theta minus 9 equals 0. 4 times cotangent theta squared minus cotangent theta minus 9 plus 4, or minus 5, equals 0. From here we want to factor. If you like, you can use a substitution, not required, but in this case we will show a substitution. We're going to substitute cotangent theta with the variable u, and I'll set my equation as 4u squared minus u minus 5 equals 0. Factoring into 2 linear expressions, we'll end up with 4u and u, and minus 5 and plus 1. Now our solutions, u equals 5 over 4, or negative 1. And again, we're temporarily using u, so let's now substitute back in cotangent theta. Cotangent theta equals 5 over 4, or cotangent theta equals negative 1. And again, the substitution is optional, so instead of using the u substitution, you can simply factor the original trigonometric equation. From here, I'll switch to my reciprocal trigonometric function. Tangent theta equals 4 over 5, or tangent theta equals 1 over negative 1, which is also negative 1. Now we'll use inverse trig functions. So inverse tangent of 4 over 5 equals theta, or inverse tangent of negative 1 equals theta. We'll use our calculator for the first value. Theta of the inverse tangent of 4 over 5 is 0.675 radians, And for the interval we're given, 0 is less than or equal to theta, is less than or equal to pi. We also want to consider a second angle. Given the function tangent, we will add pi to our first calculation to get to a second angle of 3.82 radians. Now for inverse tangent of -1 equals theta, we can also use our calculator, or you might recall that the appropriate angle here is first 3 pi over 4, and then again adding pi for our second angle within the 0 to 2 pi interval, we'll have 7 pi over 4. We've solved for theta with 4 solutions: 0.675, 3.82, 3 pi over 4, and 7 pi over 4. And this concludes Trigonometric Identities Example 1.